Preparing for SRE at HashiCorp interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define an SLO, and how is it different from an SLA and SLI? An SLI is the measured signal, and SLO is the internal reliability target, and an SLA is the customer-facing commitment, usually with consequences. For an API, I might measure successful requests under 300 milliseconds, then set a 99.9% monthly SLO. The resulting error budget allows controlled risk, such as releases or migrations. If consumption accelerates, I would pause risky work and prioritize reliability. I would define these targets from user expectations, not from arbitrary infrastructure capabilities. While answering, define SLI, SLO, and SLA precisely. Explain measurement windows, customer impact, error budgets, contractual consequences, and how SLOs guide engineering priorities and reliability decisions. Question 2. How would you design an effective error budget policy for a HashiCorp Cloud service? I would calculate the budget from the service SLO and review its consumption continuously. A fast burn could block risky deployments, while a slow burn might trigger a reliability investigation without stopping all delivery. The policy should distinguish normal releases, emergency security fixes, and customer-impacting incidents. Product and engineering should agree on it before incidents occur. For a HashiCorp Cloud service, I would also account for dependencies such as control planes, identity, and regional infrastructure. Make sure to cover budget calculation, release gates, reliability versus velocity trade-offs, burn rate alerts, exceptions for security work, stakeholder ownership, and how policy changes when service criticality or customer expectations evolve. Question 3. How would you investigate a sudden increase in latency for Terraform Cloud runs? I would first confirm the latency increase by comparing slow dashboards with customer-facing telemetry, then segment runs by workspace, region, operation, and dependency. I would inspect traffic, errors, saturation, queue depth, database performance, and recent deployments. Distributed traces should reveal whether time is spent in Terraform execution, state access, provider calls, or orchestration. If a recent change correlates strongly, I would roll it back safely. Throughout, I would communicate scope, mitigation, and next investigative steps. In your answer, discuss symptom confirmation, golden signals, request segmentation, recent changes, dependency analysis, tracing, capacity, queuing, rollback decisions, and communication with affected customers and incident stakeholders. Question 4. What are the golden signals, and how would you apply them to Vault? The golden signals are latency, traffic, errors, and saturation. For Vault, I would track request latency by endpoint, authentication and secret read traffic, error rates including permission and storage failures, and saturation in CPU, memory, disk, connection pools, and storage backends. I would also monitor seal status and replication health because a technically healthy process may still be unavailable to users. Dashboards should link symptoms to actionable runbooks rather than merely displaying many metrics. Be sure to mention latency, traffic, errors, and saturation. Connect each signal to Vault request paths, storage backends, sealing behavior, replication, alert thresholds, and customer impacting symptoms. Question 5. How would you respond to a production incident involving Vault unavailability? I would declare an incident, establish an incident commander, and quantify affected clusters, regions, and authentication flows. I would check seal status, quorum, storage health, network connectivity, and recent changes without making speculative modifications. Mitigation might involve restoring healthy replicas, failing over safely, or reverting a bad deployment. I would communicate an honest status and next update time. After recovery, I would validate read and write paths, preserve evidence, and create a blameless postmortem with owners and deadlines. Focus on incident command, impact assessment, safe mitigation, quorum and storage considerations, communication, change control, evidence preservation, recovery validation, and a blameless postmortem with measurable follow-up actions. Question 6. How would you prevent and manage alert fatigue on an SRE team? I treat a page as a request for immediate human action, not as a notification channel. I would prioritize slow violations and fast burn rate alerts, assign clear ownership, deduplicate related symptoms, and route lower severity signals to tickets or dashboards. Every page should have context, impact, and a runbook. I would review paging volume regularly, remove noisy alerts, and measure response quality. If an alert cannot drive a decision, it probably should not wake someone. Discuss symptom-based alerting, slow burn rates, actionable ownership, severity levels, deduplication, maintenance suppression, alert review, paging budgets, and eliminating alerts that do not require immediate human action. Question 7. What is toil, and how would you reduce it in a HashiCorp infrastructure environment? Toil is repetitive operational work that is manual, predictable, automatable, and lacking lasting value. I would measure time spent on activities such as access changes, environment provisioning, certificate rotation, and recurring remediation. Then I would automate stable workflows through Terraform, service APIs, runbooks, or controllers, with validation and rollback paths. I would prioritize tasks by frequency, risk, and engineer hours saved. Automation must include ownership and observability, otherwise it simply hides failures behind a new interface. Explain toil as repetitive, automatable, operational work. Identify measurement methods, automation opportunities using Terraform or APIs, safe controls, prioritization, and the balance between automation investment and immediate reliability needs. Question 8. How would you make Terraform-based infrastructure changes safer in production? I would keep Terraform configuration and module versions in version control, generate reviewed plans, and enforce policy checks before apply. Remote state needs encryption, access control, backups, and locking to prevent concurrent corruption. For high-risk changes, I would use separate environments, canary resources, staged applies, and explicit approvals. I would test modules with representative infrastructure and detect drift continuously. Since rollback is not always trivial, every change should include a recovery plan and verified backups. Cover version control, plan review, policy checks, drift detection, remote state protection, staged rollout, approval workflows, locking, automated tests, blast radius reduction, and rollback or recovery strategies. Question 9. How would you design a highly available control plane for a distributed HashiCorp service? I would separate stateless request handling from strongly consistent state, then distribute instances across independent failure domains. Replicated state needs a clearly defined quorum and leader election model, while frontends can scale horizontally behind health-aware routing. I would isolate dependencies and decide which operations can degrade during partial outages. Regional failover requires explicit recovery point and recovery time objectives, not just multiple deployments. Finally, I would test node, zone, dependency, and regional failures regularly so availability claims reflect reality. In your answer, address failure domains, stateless frontends, replicated state, quorum, leader election, regional strategy, dependency isolation, health checks, graceful degradation, recovery objectives, and operational testing. Question 10. How would you use canary deployments for a critical Go service? I would deploy the new Go binary beside the current version and direct a small, representative percentage of traffic to it. Automated checks would compare latency, errors, resource use, business outcomes, and dependency behavior against the control group. I would define rollback thresholds before deployment, expand exposure gradually, and stop on statistically meaningful regression. Database changes must remain backward compatible during the transition. Canaries reduce blast radius, but I would supplement them with load, failure injection, and delayed effect testing. Mention small traffic exposure, compatible schemas, automated health metrics, rollback thresholds, representative workloads, feature flags, dependency safety, progressive expansion, and the limitations of canaries for rare or delayed failures. Question 11. What is graceful degradation, and how would you apply it to a secrets management platform? Graceful degradation means preserving the most important user journeys when non-critical components fail. In a secrets platform, I would never casually serve stale or unauthorized secrets. Security boundaries must remain fail-closed. However, I might preserve already established sessions, isolate metadata features, or keep healthy regions serving requests while one dependency is impaired. Each degraded mode needs explicit design, metrics, and customer messaging. The goal is not to hide failure, but to reduce its blast radius without weakening confidentiality or integrity. Be sure to explain preserving core functionality during partial failure, caching boundaries, stale data risks, fail-closed security choices, dependency prioritization, explicit user behavior, and monitoring degraded modes separately. Question 12. How would you troubleshoot a Consul cluster experiencing leader election instability? I would first determine whether instability is caused by lost quorum, packet loss, excessive latency, overloaded nodes, or configuration changes. I would inspect leader changes, peer health, RPC latency, CPU, memory, disk I/O, and network errors, then correlate them with deployments or infrastructure events. I would avoid repeatedly restarting members because that can reduce quorum further. After stabilizing the cluster, I would verify service discovery and registration behavior, then address the underlying failure domain or capacity problem. Discuss quorum, network partitions, latency, clock behavior, resource saturation, logs and metrics, failure domains, configuration changes, safe remediation, and avoiding actions that worsen instability or split brain risk. Question 13. How would you implement disaster recovery for a stateful service such as Vault? I would begin with explicit recovery time and recovery point objectives, then design backups and replication around them. Backups must be encrypted, access controlled, stored separately from the primary failure domain, and regularly tested through realistic restores. I would document recovery of storage, keys, identities, networking, and dependent services, not just application binaries. For Vault, recovery also requires carefully handling unseal and recovery keys. A disaster plan is credible only when restore exercises measure actual time, data loss, and operator confusion. Cover recovery objectives, encrypted backups, key management, replication, isolated storage, restore testing, dependency reconstruction, access procedures, regional failure assumptions, data integrity verification, and documented runbooks. Question 14. How would you secure observability data without losing useful debugging capability? I would design telemetry so secrets and sensitive payloads never enter logs or traces by default. Access would use least privilege, encryption in transit and at rest, tenant isolation, audited queries, and retention limits. Structured metadata and correlation IDs provide debugging value without recording credentials or full request bodies. I would apply redaction at collection boundaries and test it with representative data. Sampling can control cost, but security-sensitive events may require stronger retention and access controls. Mention least privilege, encryption, redaction, secret avoidance, tenant isolation, retention, access auditing, sampling, secure correlation identifiers, and balancing diagnostic detail against privacy and compliance requirements. Question 15. How would you manage capacity planning for a rapidly growing HCP service? I would model demand using requests, tenants, data volume, concurrency, and workload shape rather than relying on one growth percentage. Historical trends support forecasts, while load tests reveal scaling limits and dependency bottlenecks. I would establish headroom targets, monitor saturation, and define capacity triggers before customers feel impact. Regional imbalance and noisy tenants need separate analysis. Scaling infrastructure is useful, but sustained growth may require architectural changes, quota policies, caching, or workload isolation to control cost. Focus on demand forecasting, saturation signals, workload modeling, headroom, scaling limits, dependency capacity, cost efficiency, load testing, regional imbalance, and triggers for procurement or architectural changes. Question 16. What would you include in a blameless postmortem after a major outage? I would document the customer impact, affected services, duration, detection path, response timeline, mitigation, and recovery evidence. The analysis should identify contributing technical and organizational conditions, such as unsafe defaults, missing alerts, unclear ownership, or insufficient capacity. I would preserve what worked as well as what failed. Actions need specific owners, deadlines, and validation criteria, with priority based on risk reduction. Blamelessness means examining systems honestly. It does not mean avoiding accountability for completing improvements. Include customer impact, precise timeline, detection and response, contributing conditions, technical and organizational factors, what worked, action owners, deadlines, verification methods, and prevention of recurrence without individual blame. Question 17. How would you test the reliability of infrastructure automation before broad adoption? I would test automation at several levels: unit tests for modules or helpers, integration tests against ephemeral environments, policy checks, and end-to-end acceptance tests using production-like workflows. I would verify idempotency, drift handling, partial failures, upgrades, permissions, and rollback behavior. Mocks are useful for speed but cannot replace real provider interactions. I would also run failure injection tests for unavailable APIs and interrupted applies. Adoption should proceed progressively, with observable outcomes and a clear escape procedure. Discuss unit and integration tests, ephemeral environments, provider mocking limitations, policy validation, idempotency, drift, failure injection, upgrade testing, security checks, rollback, and production-like acceptance criteria. Question 18. How would you investigate a memory leak in a long-running Go service? I would confirm a sustained heap trend rather than confusing normal garbage collection behavior with a leak. I would capture heap, allocation, Go routine, and blocking profiles, correlate growth with traffic and specific endpoints, and compare retained object ownership. Reproducing the pattern under controlled load helps isolate the cause, such as unbounded caches, Go routines, or response buffers. I would mitigate with traffic reduction or a controlled restart if necessary, then ship a targeted fix, add regression coverage, and monitor post-release profiles. Mention symptom validation, heap and Go routine profiles, allocation trends, garbage collection, load correlation, reproduction, ownership analysis, controlled mitigation, leak fixes, regression tests, and monitoring after deployment. Question 19. How would you balance reliability work against feature delivery when an error budget is healthy? A healthy error budget gives permission to take measured risk. It is not a license to ignore reliability. I would compare the feature's customer value, expected risk, reversibility, and budget consumption with planned reliability work. Low blast radius changes can proceed with progressive delivery and monitoring, while architectural risks may deserve investment before the budget is spent. I would make the trade-off visible to product and engineering, forecast likely consumption, and revisit SLOs if actual user expectations differ. Explain that a healthy budget permits measured risk rather than unlimited risk. Discuss user value, reversibility, blast radius, reliability investment, forecasted budget consumption, stakeholder alignment, and continuous slow review. Question 20. Describe how you would lead an incident when several teams own different parts of the dependency chain. I would establish one incident commander and separate roles for operations, communications, subject matter investigation, and scribe duties. We would create a shared timeline, state the customer impact, and assign hypotheses to owners rather than having everyone investigate randomly. Each team would report evidence, confidence, and next action on a fixed cadence. I would prioritize reversible mitigation over perfect diagnosis, escalate through documented paths, and keep stakeholders informed. Afterward, teams would jointly own follow-up actions and dependency improvements. Cover incident command, clear roles, shared timeline, service ownership, hypothesis-driven investigation, escalation paths, communication cadence, decision logging, customer impact, mitigation, and post-incident coordination across teams. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.